Here we go. Ooh, going to get a little harder one here. Here's where now the simplify comes into the problem. I'm going to rewrite this problem now two ways. First off, I'm going to do what I did before. I want an x squared on top, and I want a constant. That's the right term, constant on the end. That's why you see 0x squared plus x plus 0, because there are no values there. And here I have x squared minus x minus 2. But before I begin and do any other work, I'm going to do another step. And on a lot of these graphs, and on the ones on your test, you will need to do this. You will need to have it written this way, and you will need to have it written factored. So I need to factor this. Now what are the factors of 2? 1 and 2, which 2 minus 1 does make 1. So that's going to be a factor with an x with a 2 and a 1. X squared minus x minus 2 factors to x minus 2 times x plus 1. I want these written both ways because we're going to need to solve the problems using, some of them we'll need this one, and some of them we will need this one. The first thing let's find is the y-intercept, because the y-intercept is usually pretty much the easiest one to find on all the problems. The y-intercept is just these numbers right here with no x's. So the y-intercept is at 0 over 2, which is just 0, 0. To find the x-intercept by setting the numerator equal to 0. Well, the numerator is just the x. So the x equals 0, so the x-intercept is at 0, 0. Now I'm going to give you a hint. If the y-intercept is 0, 0, guess where your x-intercept's always going to be also? At least at 0, 0, because that's the same point. I next need to find my vertical asymptote. How do you find the vertical asymptote? Set the denominator equal to 0. There's the denominator. Coach Stoney, how do I do that? Well, you set each one of these parentheses to 0, because remember, if this parentheses is 0, 0 times anything gives you 0. So I know 0 equals x minus 2, or 0 equals x plus 1. That one I'm going to add 2, and this one I'm going to minus 1. So, ooh, I have 2 asymptotes on this problem. Not uno, but 2. I have one at x equals 2 and one at x equals negative 1. Ooh, it's going to make our graph a little bit different. So now how do I find the horizontal asymptote? By looking at the leading coefficients. Now notice, this has an x and that has an x squared. That's why I wrote 0x squared and x squared, because my leading coefficients have to be the same degree in order for this to work. This is now 0 over 1, so I have a horizontal asymptote at, well, wait a minute, Coach Stoney. If I have a horizontal asymptote at y equals 0, and I have a y-intercept at 0, 0, is that possible? And the answer is yes, because there were 2 vertical asymptotes. Remember, an asymptote occurs as you're approaching infinity. At 0, are we approaching infinity? No. So therefore, it is possible still to have that in the middle, but then the asymptotes occur only as you're moving out to infinity and beyond. Little Buzz Lightyear there, all right? You get a Buzz Lightyear picture maybe, all right? So here's what we have as we go to graph this. Oh, looks like I've got a point already in there. I need to probably fix that. But anyway, here we go. There's our vertical asymptotes. I have one at 2 and one at negative 1. I have a horizontal asymptote here, but notice I made the horizontal asymptote only going out and not in the middle. I know we have a y-intercept and an x-intercept. And what I also need to do is this. That's this point right here. I already got the answer marked up there. Forgot to have that pop in there. But anyway, I pick a number between negative 1 and 2 besides 0, because I know 0 is already there. So I need to know whether this graph goes up like this, goes down like this, or could it go a combination thereof? So I need to pick a number right of this and left of this, and 1's the easier number. If I plug 1 into this, 1 squared is 1, minus 1 minus 2, I get equals negative 1/2. So notice, at 1, I am at negative 1/2. I put a dot there. That was the one that was left up on there. I also need to check negative 1/2. I can't go negative 1 because that's this red line, and 0's here. So I'm going to put in negative 1/2. Or you can put negative 0.5 in your calculator if it wants to make it easier for you. So I have negative 1/2 here, negative 1/2 squared minus, now I did all mine in fractions. Negative 1/2 squared is positive 1/4. Negative minus a negative makes it plus 1/2. The negative 1/2 here minus 2. I got to get common denominators for all of this. 1/2 is the same as 2/4. 2 is 8/4. 1 plus 2 is 3 minus 8 is negative 5/4. Oops, that's an upside down. You're turning me. Giving love instinctively. Reciprocals. The negative 5/4 becomes really negative 4/5 and negative 1/2, but negative negative cancel. And I can cross cancel that out and end up with 2/5. And really, I didn't really have to go any further. All I really needed to know was, is it positive or is it negative? If it's positive, it's going to put a dot right in there. So what that means is, this graph will do something like this. It will be a cotangent graph. It's going to look like cotangent. That's what that part's going to look like between there. I also need to pick a point left of here to know whether I'm going to have a curve up or a curve right there. So I picked 3 because that's the first number larger than 2. And I plug it in, plug it in. So I have 3 squared minus 3 minus 2, which is 3 over 9 minus 3 minus 2, which will be 3/4. 3/4 is positive, so I know I'm going to be right in there. So I know this one's going to be a curvy one like that. I need to check one over there. What number do you want to use left of negative 1? I think I want to use negative 2. Oh, I did. Good. I used negative 2. I'm glad I did. Trying to make my math easy. Negative 2 here, negative 2 there. Plug it in, plug it in. Don't you wish I could sing? You end up with this here. Hey, these 2's are going to cancel. Negative 2 over 4. Negative 1/2, which means it will be down here. So this one will be here. I'll have like a cotangent down, snaking down. Right there. And there we go. Oh, looky there. I graphed it right. This one had 2 vertical asymptotes. We ended up having really 3 different distinct graphs. I had to actually use 5 points to know just which way to curve the lines. The smooth curving lines, that was our guideline 7. Woo! Woo doggies, but isn't that cool to do stuff like this here? And it's really not all that hard as long as you can find the X-intercepts and a couple of points. X and Y intercepts, all right? If we go ahead and cut it off now.
Yeah.
Okay.